Some stories are hidden in the shadows. Welcome to DarkLens.
What if I told you that somewhere in a dark forest, a spider can lose control of its own mind, not to a predator, not to a disease, but to a tiny wasp. A wasp that forces the spider to build a home for its killer. A wasp that turns a living creature into a slave. And when the work is finally complete, the spider is eaten alive. This sounds like something from a horror movie, but it's real. And tonight, we're uncovering one of the most disturbing examples of mind control ever discovered in nature. Deep within a dark forest, an orb-weaving spider begins another ordinary night. Like it has done countless times before, it carefully repairs its web. Every strand is placed with precision. Every movement follows an instinct, perfected over millions of years. The web is its home, its hunting trap, its survival. For hours, the spider waits patiently in the darkness, sensing every vibration that travels through the silk. To most creatures, it is the hunter, but hidden nearby is a predator unlike any it has ever faced. A predator that doesn't rely on speed, or strength, or sharp teeth. Instead, it uses something far more terrifying: control. And once the attack begins, the spider's fate is already sealed. The victim in this story is a species of orb-weaving spider known as Cyclosa argentio-alba. These spiders are master architects. Every evening, they construct intricate circular webs designed to capture flying insects. The web isn't random. Every thread has a purpose. The outer frame provides support. The radial lines act like spokes on a wheel, and the sticky spiral traps anything unfortunate enough to fly into it. For a spider, survival depends on precision. One mistake can mean starvation. But despite all its skills, this spider has an enemy it can barely detect. Hovering silently through the darkness is a parasitoid wasp called Reclinervelis nielseni. At first glance, it doesn't look dangerous. It's small, lightweight, almost insignificant. Yet this tiny insect possesses a strategy so disturbing that scientists still study it today. Because unlike ordinary predators, this wasp doesn't simply kill its prey, it takes control of it. One evening, the wasp finds its target. The spider sits motionless at the center of its web, waiting, unaware. The wasp moves quickly. In a matter of seconds, it attaches a single egg to the spider's abdomen. Then it leaves. No dramatic battle, no visible injury, no sign that anything is wrong. The spider survives the encounter and continues its life as normal. It hunts, repairs its web, captures insects. Everything appears unchanged. But the real danger has only just begun. Days later, the egg hatches. A tiny larva emerges and anchors itself to the spider's body. From that moment on, the spider is no longer alone. It is carrying a passenger that will eventually become its executioner. As the days pass, the larva begins feeding. Not enough to kill the spider. Not yet. Instead, it slowly drinks the spider's hemolymph, the spider equivalent of blood. The process is surprisingly careful. The larva needs its host alive. A dead spider would be useless. So it feeds, slowly, patiently, like a parasite, managing a valuable resource. Weeks pass. The spider continues performing its daily routine. To an outside observer, everything looks normal. But attached to its body, the larva is growing larger, stronger, hungrier. Scientists studying these interactions notice something remarkable. The parasite never enters the spider's brain. It doesn't physically take over the nervous system. It remains outside the body. And yet somehow, it is still able to control the spider's behavior. How? That question led researchers to one of nature's strangest discoveries. Because the wasp doesn't need to invade the brain, it simply rewrites the spider's instructions. As the larva approaches its final stage of development, something changes. The spider suddenly stops behaving normally. Its routine begins to break down. Instead of building a standard hunting web, it starts creating something completely different, something it would never normally build. Scientists call it a cocoon web. At first glance, it looks strange, simpler, stronger, purpose-built. And most importantly, it isn't designed to catch prey. It's designed to protect the parasite. The spider works tirelessly, reinforcing strands, strengthening anchor points, adding structural features never seen in its ordinary webs. Researchers discovered that some of these silk threads can become many times stronger than those found in normal webs. The spider is no longer acting in its own interest. It is following instructions. But where are those instructions coming from? The answer may lie in chemistry. Scientists believe the larva releases compounds that mimic the spider's own hormones. One leading theory involves a hormone called ecdysone. Normally, spiders use this hormone during molting. When it's time to shed their old exoskeleton, they construct a special resting web. The parasite appears to exploit this existing behavior. Instead of inventing a new command, it tricks the spider into activating an ancient program already hidden inside its brain. The spider thinks it's following its own instincts, but every movement serves the parasite. Imagine spending your final days building a fortress, working tirelessly, strengthening every wall, perfecting every detail, only to discover that the fortress was never meant for you. That's exactly what happens to the spider. The cocoon web becomes a masterpiece of engineering, strong enough to withstand wind, rain, falling debris, even accidental collisions from other insects. Everything about the structure benefits the parasite. Nothing benefits the spider. The victim has become an architect, a laborer, a slave. And the most disturbing part? The spider has no idea. It continues working until the task is complete. Only then does the parasite reveal its true purpose. Because once the cocoon web is finished, the spider is no longer needed. The larva has reached maturity. Its shelter is complete. Its future is secure. Now it turns on the creature that built everything for it. The spider that carried it, fed it, protected it. The spider that unknowingly sacrificed its final days. The larva kills its host. Then it feeds on the spider's body. The victim that once controlled the web is reduced to food. Afterward, the larva settles into the cocoon web the spider created, suspended safely above the forest floor, protected by reinforced silk, protected by the very structure its victim was forced to build. Inside the cocoon, the parasite transforms. Days pass, weeks pass, and eventually a new adult wasp emerges, ready to begin the cycle again, ready to find another spider, another victim, another slave. But the story becomes even stranger. Scientists made a shocking observation. When the larva is removed, before the final stage, the spider often returns to normal behavior, almost immediately, as if waking from a nightmare, as if the mind control suddenly disappears, which means the spider was never choosing to help the parasite. Every reinforced thread, every strand of silk, every moment spent building that cocoon web was the result of chemical manipulation. And perhaps that's what makes this story so unsettling. The wasp doesn't overpower its victim. It doesn't chase it. It doesn't fight it. Instead, it transforms the spider into an obedient worker, a living tool, a creature programmed to ensure the survival of its own killer. Nature is filled with predators, but few are as terrifying as the ones that don't kill immediately, the ones that take control first. And somewhere, in a dark forest tonight, another spider may already be spinning the final threads of a web that was never meant for itself. A web built for the monster on its back.